see. Okay. If you close your eyes, hey-oh, hey-oh. Okay. So, welcome everyone to my channel. Today we'll actually be reviewing section 3, chapter 3 of the launch code Java track. And currently we're just waiting on students to see if anyone's going to filter on by. We'll give them a few minutes and then we'll get started. All right, so we'll just go ahead and get started. So today we'll be reviewing control flows and collections, fairly basic stuff that you should have read about in the JavaScript side of things. Can everyone hear me? Yes, good. Okay. Let's see, something's going wonky with my stream. No, looks like we're back up and good again. Okay. So, as I was saying, today we'll be reviewing control flow and collections. Collections are something that everyone here should be relatively familiar with. We've had these previously, nothing new that we're touching on, no new ground. So we'll just go ahead and get started. First of all, conditionals. Conditionals we've touched based on in the past, nothing new here. If statements. Everyone remembers if statements. Now, the only thing with if statements is they can be a little different than what you're used to in Java. I mean, the syntax itself, it's easy. You just put if, your condition in parentheses, and then what needs to be executed inside of brackets. So we're actually going to go ahead and run one of these in our IntelliJ. Let's see. So let's just do this. Excellent. And we'll just do a general if statement. And let's just do if. Actually, let's do this. Let's do integer AB equals 2. All right, so our if statement says if AB is greater than 1, console, lowercase c, console.log, no, not console.log, system.out.println greater than 1. So if we go ahead and run this, and actually there's one thing that we're missing here. We are missing this little bit right here, our public static void main argument. We'll just copy that and paste that in here and add the bracket we're missing there, save, and run. So here you see that it went with, hey, AB is greater than 1 because it's assigned 2. So it successfully launched what was in our if statement. We'll go ahead and continue on to the next section, which is all right. So we've done if statements. Now we need to do if else statements. Pardon. All right, I'm back. My apologies for that. So now we're going to do if-else statements, which is essentially saying, hey, you have a condition. If that condition is met, you're going to do whatever is listed on line 2 and 3. If it's not met, we're just going to add a fail-safe that you need to do in the meantime. Fairly simple stuff we've touched base on again in the past. So let's pull back up IntelliJ. And let's just add on to this. Else system.out.println and failsafe 101. Okay, so now one thing to note is else doesn't need a condition because else will execute no matter what, assuming that nothing above it has met the criteria. Easy enough. So let's change AB to 1 and let's run it. And forgot a semicolon. That will happen a lot. And so failsafe 101 kicked in. Why? We instructed here that AB had to be greater than 1. And here AB is equal to 1 on the dot. So since this condition was not met, it immediately went and executed the else statement. Easy enough. We'll go ahead and move on to the next bit, which is else if. So the syntax is kind of wonky, but essentially else will be your very first condition. Else if will essentially have any other conditions that can be met. And then else will be your failsafe, which is, hey, if no conditions above this are met, then this needs to be executed. Simple enough. And you can have technically an unlimited amount of else ifs. Just, proceed with caution on that one. So let's go ahead and go back into IntelliJ. And we're just going to do an else if our condition okay. So one thing to note here is else if does need a else if does need a specific criteria. So let's say AB equals 3. And now let's change AB to 3. Then here we're going to do system.out.println and we'll console AB is 3. Okay. And we will go ahead and launch it. We have an issue. Oh, right. So very similar to JavaScript. Remember, single equals is an assigner. Like here we have AB equals 3. That's assigning the value of 3 to AB. Double equals is a loose comparison, and I think triple equals is a thing in Java. But don't take my word on that one. Do your own research because, yeah, no one's infallible. So we'll wait. So greater than 1 still executed because technically speaking, AB being 3 is still greater than 1. So we're going to go ahead and change this to AB equals 1. Double equals 1. And let's go ahead and run. So now we have AB is 3. And theoretically, we could just copy that, paste, and let's see what happens if AB is 4 or 5. And let's go ahead and change this to 5. And I forgot to do a couple of things here. Okay, and now let's run. Don't mind the little red dot. That's just a That's just a debugger flag, but nothing to worry about. So integer AB is 5. We've noticed that if AB double equals 5, it needs to print out AB is 5. So that's all about if, and else statements. All right, let's switch back over to our assignment. There we go. Switch statements. So Java does support switch statements, which act kind of like an else if statement. So Java does also support a switch statement, which does act somewhat similar to an else if statement. Under certain conditions, which are called cases. The switch statement isn't really used very often, and we generally recommend you avoiding using it. It's not as powerful as the else if model, because the switch variable can only be compared for equality with very small case of types. Here's a quick example of a switch statement. So we have JPrinter. It asks, hey, enter an integer. Then it takes, in the case that it has 0, it will actually reassign the day string to Sunday, case 1, Monday, case 2, and we can actually run this ourselves. So let's go ahead and do that. So copy. And let's honestly go ahead and make sure that we import that package. So import java.util.scanner. And let's just comment that out for now. Okay. We'll just command V. All right, there we go. Perfect. Okay. So now when we run this, it asks you, hey, enter an integer. Let's enter what? 0 is Sunday, 1 is Monday, 2 is Tuesday, 3 is Wednesday. Let's enter 3, I think. Yep, Wednesday. So fairly simple, not a lot of frills here. It's essentially changing out the value of something, or you can, in the case that you have a specific value being passed into you. Not a huge deal. All right, let's go ahead and swap back. Oh, I'm not even sharing my screen. Oh, love that. There we go. My apologies for that. I'm still getting used to this. So essentially, we've gone on ahead and pasted our code in here. We commented out our code here. We have all the code that was entered in here. And when we run this, enter an integer. Let's enter 1 for Monday and Monday. So the syntax is fairly simple. You have a switch and then daynum. Daynum is very simply whatever variable is being passed in by our scanner. And based on the case being whatever criteria it is, if it's 0, 1, 2, 3, 4, 5, 6, or 7, then it will assign day Sunday, Monday, Tuesday, and then it will print it. The default is just the failsafe, kind of like an else in an else if statement. No matter what happens, if none of these match up, this will run. Then it just prints it out. So let's go ahead and do 77. Oh, 77. Okay, we're good now. Let's go ahead and continue. Okay. Let's go ahead and swap back over to our book. Okay, so in the example above, here's the output of the user enters 4 for Thursday. And the output of the user enters 10, which we already did, which the int does not correspond to a day of the week. Here is how to construct the above using an else if construction. So you have the scanner, you have everything being put in. It's the same thing. If your daynum double equals 0, day is Sunday, day num double equals 1. Remember, we use double equals because we're actually doing we're comparing, we're not assigning, and we go through all of the days. Then our else statement is the same as our, what was it called on this thing? As our default statement up here. Else day equals int, simple enough. Fall through. So additionally, if break statements are omitted from the individual classes on accident, a behavior known as fall through is carried. Fall through can be kind of intuitive and is only desirable in very specific circumstances. We will discuss break statements in more detail in the loop section. For now, just know that when you use a switch block, they terminate the switch statement they're in, so the flow of your program moves on to the next statement after the switch block. Here's a quick sample of how fall through works. So you have your scanner. You ask for an integer, you get it, you assign it to day num. You have everything here. Then you have your default. And let me go ahead and actually copy and paste this. And let's open it up in IntelliJ. Okay. So we might have brought in a little too much. Let's go ahead and remove these two. And remove. All right, and now let's go ahead and click play. I think that should work. Yep, that works. Excellent. Okay, asking us for an integer. We'll pass 1. And here it's telling us, hey, the int doesn't correspond to a day of the week. Simply put, we have a string day, switch day num, case 0, day equals Sunday, day equals Monday, day equals Tuesday. Default. In this example, this block runs even if one of the above blocks matches. Day equals int does not correspond to a day of the week. We've seen that that does happen. Let's swap back over to our book and see why. Okay, so we don't have the break statements in each case as we did up here. Break. Without those, without those break statements, the loop actually continues to come down through the entire switch statement until it hits the bottom. So that's kind of why else if statements are a little more powerful than switch statements, because switch statements require that break in order to stop and be smart enough to go, hey, this is where I need to stop. Whereas case will continue to go from top to bottom and will eventually hit that default behavior. So, yep, proceeds to execute every statement in the case that follows, all the way through default. So string ends up being printed. Along similar lines, consider this variation of the code above. String day, switch day num, case. So here they added break at the bottom, which means that here every day will be Saturday, because it will continue to run down all the way until it hits this break, and it goes, oh hey, one of these conditions is met, which technically it'll still break here no matter what, but yeah, it's kind of complicated, but it is what it is. So if you enter an integer with this, it will continue to process all the way through 6, then it'll break once it hits here. Okay, simple enough. Question, when does fall through occur in Java? Omitting an else clause? No. Omitting an else clause from a switch statement? No. Omitting a default case from a switch statement? No. Omitting a break line from a switch statement? 100% yes. We need our break lines. Okay. Let's see. Given the above code above, what prints if the user enters no after the prompt? So are you a space cadet? Yes or no? Takes the answer. So switch, if yes, System, print out, print lane, greetings cadet. Case no. System, print lane, greetings normie. System, out, print lane, are you an alien? So what will be printed out here is actually it will actually print out C, greetings normie, and are you an alien? So remember, it will still print out this because you're still meeting the case by entering no. But since there's no break statement, it will continue to process until it hits this default statement. So it'll print greetings normie, are you an alien? All right. No questions on that in the chat. Let's just go ahead and continue. On to loops. So for loop. In Java, we write a definite loop or a for loop as follows. So for, here we have our initializer, which is where we begin. We have our condition, which is what needs to be met. And we have our step, which is I++. Then we print out whatever I, and here's our output. If we put this into IntelliJ, it's simple enough. Let me pull up IntelliJ. Okay. And let's just go ahead and comment all this stuff out yet again. Gonna have a huge file. So let's say that we have, yeah, we're fine. Okay. Are we? Yeah, we are. Okay. So let's see. So for int I equals 0, and let me check something here. Yeah, okay. So I equals 0, as long as so int I equals 0, that's where we're starting. I is, as long as I greater than 10 maybe? Okay. And then I++, we'll do a system.out.println, and we'll just print I. Okay. So let's go ahead and run this and see what happens. Yep, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So normally this is where I would ask the class, hey, who can tell me why we only got to 9 even though we put 10? It's because, as usual with programming, we start counting at 0 instead of 1. So if we actually wanted to hit 10, we would do 11. Now, cool thing that you can technically do here is, let's say that you had AB equals 10, and let's do integer AB equals 10, and let's see, I is greater than AB plus 1, and let's go ahead and run this. Let's see if this will actually work. Up. All right, and let's run it again. So yes. Now this is technically a way to make it a little more dynamic, just in case you have that question or you need that information. But 9 times out of 10, when you're looping through a collection, you want that count, and you can do like AB dot, if this was a collection, you could do length dot value, etc. I don't know if value is a thing, so don't quote me on that. Okay. Let's go ahead and swap back over to our book. Okay, so that's a for loop. We may not be familiar with the expression I++ since it isn't found in all languages. Plus plus is an incrementer, which is I is equal to I plus 1. So the Java for loop gives you explicit control over the starting, stopping, and stepping of the loop variable inside of the parentheses. And here we have the same syntax I just explained. For start clause, stop clause, step clause. Okay. Now for each, Java also provides a syntax to iterate over any sequence or collection of array, such as here we have array of nums, 1, 1, 2, 3, 5, 8, and here we iterate through them. Let's go ahead and run this and see what happens. Okay. And we'll just comment that out. Okay. Okay, and let's actually get rid of this, and this, and this. Okay. Yep. Forgot one. There we go. Okay. So we have int nums, blah, blah, blah. And this syntax is very simple. Int I. Let's actually run this. I'm curious. Okay. So this is very simple. This is essentially the same syntax we've had in JavaScript, which is and here we have I in nums. So I is just the beginning, nums is a collection. So for every I in nums or for every number in nums, print it out, which is what it did down here. Now, notice here it printed out everything. It didn't start off at a zero index. It just went through the entire collection. Good to know. All right, let's go ahead and continue. Okay, there we go. Okay. Yeah, so the for each loop, which is what we went through, and this is essentially for each for each number I in nums, print it out. The loop version also works with a string, where we can convert the string to an array of characters. String message equals hello world for every character C in message to character array. To character array just changes this right here from hello world string to an array with each character in an index. Simple enough. And if we copy this, too much. Yet again, too much. There we go. Copy this. Swap back over to IntelliJ. And let's just go ahead and paste that. Okay. And let's go ahead and run it. And let's do this actually. Yeah, so let's do so here we've converted it into an array, and now we're gonna print it out. Oh, nope, not car. This is a. Man, I can barely see that. Okay. And now let's try running it. And if we scroll up, we see here we still have our character array, which is hello world. It just didn't print off as an array, which is fine. That's bound to happen. Okay, let's continue and swap back over to our book again. Okay. I wish I knew why my mic likes to shut itself off, but whatever. So, like I was saying, int I equals 0, while I is less than 3, system out print lane I, and then it'll increment I by 1. So here we have 0, it printed itself out, then it added 1, which is why we have 1, then it added 2, which is why I have 2, then it added 1 more, and once it hit that 3, this condition was no longer true. So that's why we never hit 3. Now we can do an equals here. Oh, is it the other side? I don't think that doesn't look right, but let's try it. Oh, okay, so that was right. Okay, so while I is less than or equal to 3, it actually printed it out correctly, so no issues there. Let's go ahead and continue through our loops. Going back to our book, let's see. There we go. Okay. So do while loop. So Java also adds an additional, if seldom used variable in the while loop called the do while loop. Essentially, the do while loop is very similar to while, except that the condition is evaluated at the end of the loop instead of the beginning. This ensures that a loop will be executed at least once. Some programmers refer to this loop in some situations because it avoids an additional assignment prior to the loop. So here we have print out hello world while something is false. So this will print out at least once, even if this condition is never met. And we can actually show you this in IntelliJ. Yep. There we go. If we run this, it still printed out hello world, even though it never had anything to meet this. That's because it will it will execute it at least once, then it will stop. And now let's go ahead and do this. Boolean guilty equals false. And we'll do guilty double equals. That should work, right? Let's try it. Whoa. That's what we call an infinite loop. Oh. Cancel. Stop. Let's see if does that work. Okay, so single equal. Yeah, for some reason that worked. Did I spell that right? G-U-I-L-T-Y. Maybe it's supposed to be bool? Nope. No, that doesn't work. But yeah, so essentially as soon as this was deemed to be true or reassigned in this case, it stopped. Since it did not in the previous case, that's why we had that infinite loop happen. That does happen a lot, so don't feel too bad if that does happen to you. All right, let's continue on in our book. Let's see. Break statements and loops. There are instances where you may want to terminate a loop if a given condition is met. In these instances, the break statement comes in handy. Let's say that you want to loop through an array of integers to search for a given value. Once that number is found, you want to quit the loop. You can do the following. So we have a collection of integers. We have the one we're looking for, which is 10, the second one. Then we have for every int in some ints. If one int double equals our search, we print founded and break. Yeah, let's take this and play with it. Let's see. Oh, too far. There we go. Okay, so let's go ahead and delete that. Paste that. Oh. Oh, that's why. Okay, so here we have int sumint 1, 10, 2, 3, 5, 8, 10, and we've actually already reviewed this. This was the exact same thing that happened with our switch statement. Without the break, it'll just continue executing. So let's actually remove the break first. And let's run it. So here it printed that out twice because it was in there twice. Okay, fair enough. Let's re-add the break and run it again. Printed it out once. What this essentially means is it stopped at the very first instance that it hit it, and then it just didn't continue anymore. But let's do this. Let's just system.out.println, and here we're gonna do 1 int. Okay, and let's go ahead and run it. So here we just loop through system.out.println, and let's go ahead and remove this one. Okay, and run it. Okay, so here we printed out 1, 10, and found it. If we remove the break, we actually go through the entire array for when we found it. Now let's leave the break in, and let's just change our parameters a bit. Instead of 10, we want 5. So with the break, it stopped as soon as it found 5. Without it, it continues to loop through the entire collection, which is not necessarily optimal, especially when you're writing programs that you need to save system resources on. So that's the basics of our looping through a collection and our break statement. And let's swap back over to our book, see if we missed anything. Okay. So we already confirmed this. Note that a break statement terminates the innermost loop that it contained within. So if you have nested loops and use a break statement within the innermost statement, it will only terminate that loop and not the outer loop. If a break is present in the outer loop and any other block nested within it, it is terminated when the break runs. Okay. So continue statements in loops. Okay. The continue statement is similar, but importantly different from the break statement. Like break, it interrupts the normal flow of the loop, but unlike break, continue statements only terminate the current iteration of the loop. So the loop will continue to run from the top as long as the Boolean expression that controls the loop is still true. After a continue statement, here's an example. So okay, fair enough. Let's go ahead and take this and run with it and swap back over to our IntelliJ. Actually, this is a different loop. Let's go ahead and copy this. IntelliJ. All right, let's see. Okay, and now let's run it. Okay, so here it went not here, not here, not here, found it, not here, not here. So let's go on ahead and remove this continue statement and play it. So here it printed it out. It printed it out once. Let's actually change that back to 10. Ran it regardless. Okay. let's swap back over to our book because I'm kind of confused. Let's see. The above program will print not here for every iteration except where the number has been found. So the output looks like this. Because of that continue statement, the final print statement for the loop is skipped. If the continue statement weren't there, the output would look like this. Notice the extra not here printouts. Okay. This is really hard to visualize. So yeah, 10. So with the continue statement, it just goes not here, found it, not here, not here, not here, not here, found it. So essentially, a continue statement will continue a loop, even if it should already meet an escape condition, like a return or a system.println, etc. A continue statement just says, hey, you're good to continue. Just go ahead and keep looping through the entire collection. Simple enough. So check our understanding. We have a characters of PLRST for loop statements, system.println I. What does the missing loop statement need to be to print each item in characters? And this one is actually A for car I in cars. Remember, we don't need this because we already see that it's a collection up here. And we can actually scroll right up here. And let's see. Yeah, for int I in nums. Easy enough. Do system.println hello world while 3 is less than 2 is, yeah. How many times does the message print and why? 0, the while condition is never true, or 1, the print statement is evaluated before the conditional, or C, infinite times. 3 is less than 2 and the condition is never changed in the loop. So this one's kind of tricky, but I would honestly say B, because the print statement is evaluated before the conditional. Remember, with a do while loop, it will always execute at least once, since it does whatever it needs to do before it runs that conditional. Simple enough. Okay, now let's move on to collections. And this is where we get into data structures, and you'll hear a lot about data structures and algorithms as you continue learning about Java or really any programming language. So it's good to get familiar with them, but for now, just data structures. So a data structure lets us hold a lot of data in a single place. It's a programming construct that aggregates lots of values into one value. Many types of data structures exist in various languages. We have lists, dictionaries, arrays, tuples, etc. So Java provides powerful and flexible structures to store data known as collections. The Java Collections framework refers to the various interfaces the language uses for implementing collection types. So we'll discuss array list and compare it to the array class. We will discuss hash maps and I guess arrays as well. This doesn't really explain it too well. But there is official Java documentation on collections. And if you ever have time, I do highly recommend just reading through the documentation. It is very, very technical and very in-depth, but don't let that scare you. Okay, so we're actually going to do a gradebook 3 different ways. So we'll explore collections in Java by looking at different versions of the same program. The program functions as a gradebook, allowing a user, which is a professor or a teacher, to enter the class roster for a course along with each student's grade. It then prints a class roster along with the average grade. In each variation of this program, the grading system could be anything numeric, just such as 0.0 to 4.0 point scale or a 0 to 100 percentage scale. So a test run of the program might yield the following. Enter your student name. Here you have your names, your grade for Chris, Jesse or Sally, the roster, and the average grade. So first we're going to start with array list. All right, so to write an array list version of the program, we'll need to introduce several new Java concepts, including the class array list. We'll also review different kinds of for loops used in Java. So before going any further, we suggest you run the ArrayList gradebook program in IntelliJ. You can view this program in your Java Web Dev exercises. So let's go ahead and do that. So let's see. Is that this one? Yep. All right. So which one are we doing? ArrayList gradebook. Okay. And let's go ahead and do that one. And let's run it. Okay. Oh, right. Okay. Enter your students. Let's say that we have Antonio, Will, and Gia. So we have 3. And we have to tap enter again to finish. Antonio did pretty well. He got a 3.0 out of 10. Will did all right. He got a 5.0 out of 5. And Gia's just crushing it. She's got a 10.0. Okay, so our class roster is Antonio with a 3, Will with a 5, and Gia with a 10. She somehow doubled their average. So our average grade for the class is now a 6, and we'll finish with our exit code. Here we have the code. We're just going to look through some other pieces before we really step through this. Okay, and here's just the same code that we have over there. Let's actually step through it. So we have an array list of string students, which is just a new array list. We have an array list of double grades, and then a scanner to ask us pieces of information. And we have string new students. This is where we ask enter your student's name or double and tap enter to finish. So we have a do statement. So this is where we assign new student input.next line. And this is where we assign that first student name to new student. Then here if new student equals blank, students.add new student. Now, one thing is this actually changes it into a falsy statement. So new student equals blank becomes if new student is not blank, add that to new student. While the new student is not equal to blank. Easy enough. The student grade for every string student in students, print grade 4, and then the student name, double grade equals input next double, grades.add grade, and here you just have the class roster. This /n is, I think, an enter, so don't get too frightened about that. Double sum equals 0.0. For every student, you're going to do students, you're going to get the index of each student, and then you're going to add their grade. You're going to sum everything up. Then you're going to do sum divided by the size to print out the average grade. Okay, a lot going on, but we can continue to step through it. Here we declare and initialize 2 objects, which appear to be of type ArrayList string and ArrayList double. An array list in Java is very similar to an array. Like an array, we must let the compiler know what kind of objects our array list is going to contain. In the case of students, the array list will contain values of the type string, representing the names of the students. So we'll use the array list string syntax from the compiler. Similarly, our grades will hold exclusive values of type double and is declared to be of type ArrayList double. Okay, note that we declare grades to be of type ArrayList double using the wrapper class double rather than the primitive double. All values stored in Java collections must be of objects, so we'll have to use the object types in those situations. In lines 10 and 11, we also initialize each list by creating a new empty list. Note that when we call the ArrayList constructor in as new ArrayList, we don't need to specify type. It's implicit from the left hand of the assignment. Note, we'll sometimes see ArrayList class written as ArrayList E, where E represents a placeholder for the type that the programmer will declare a given list to hold. This is especially true in documentation. You can think of E as representing an arbitrary type. So classes like ArrayList E that take on another type or a class as a parameter are referred to as generic classes or generic types. Give me a second. All right, that's back, and that's back. Okay, perfect. So let's go ahead and continue. Array list iteration, do while. We then use the do while list loop to collect the names of the students. So this will always execute once and checked at the end. Oh, actually, we do. Okay, so that kind of explains a little more. Let me set this actually. Let's do this. Okay. Okay. Oh, lovely. Okay. So I think you should be able to see it now. Let's do. Is there a way to collapse this? Oh, there we go. Okay. So the array list iteration here, do while, which is right here. Perfect. So do new student, which is this string right here, is an input.next line. So when you hit enter, if new student equals blank, but this is not. So if your new student is not blank, your students, which is your array list, it adds whatever you put into this array list. Simple enough, while new student is not equal to blank. So as long as new student is not blank or you don't hit enter twice, it will continue to add students to this array list student. And let's actually do this. System.out.println. And let's just print out new student. Value entered is plus new student. And let's just go ahead and run. Okay. Antonio, value entered is Antonio. Gia, and Mikey. And then now, here's the thing. You see here, while new student equals blank, not equals. So let's see what happens if we don't enter anything and we just hit enter again. It continues. It escapes this loop and proceeds to the next one, which is where it actually gets the grade. Let's go ahead and continue. So below the do while list are two different loops that demonstrate two ways you can loop through a list in Java. Here's the first, which collects the numeric grade for each student. So for every student in students, which we've already established, students is our array list. System.out.println grade for, then the student then it will take whatever you put in and add it to our grades double right here using the grades.add grades. So grade for Antonio, he got a 95. He did okay. Gia did 100 as usual. And Mikey's, he didn't study too well, so he actually got a 35. So let's go ahead and hit enter. Now, one thing to note here is student in students. Since students, the array list has a set value, it will actually only ask you for however many students are in that student's array list. And now, once this for loop was escaped, it just printed it out, which went, hey, your class roster. It just initiated a sum of 0.0. For every student, you printed out the grade, and you summed up all of the grades. Then you divided the sum of the students by the size, how many there are. Then you just printed out the average grade, which is 76. Mikey really brought the average down. Yeah, okay. So here we introduce students.size, which utilizes a size method of the array list. We've used the size method before. It's not necessarily anything new. Yeah, we use a loop index to define the starting point, ending point, and increment iteration. So starting point, ending point, increment iteration. So for integer I in the range of the number of items is it's a nicer way to visualize it. So we've already discussed this. The syntax plus plus just adds 1. And our array list method. Let's gather up a few of the array list methods that we've encountered so far. We have the documentation. To demonstrate the use of these methods, we'll create a new array list called planets, string, planets. Okay, we've got an empty array list. And let's actually do this ourselves. Where is it? Here it is. Okay. And let me clear out some of this because it's getting a little much. Okay. And let's just do an array list of string planets is equal to a new array list. Okay. And we'll use the dot add to populate the planets. So planets.add. We're just going to add the best ones. Mercury, Venus, Earth, we're number 1, and Mars. You know what? I actually feel for the little guy. He got demoted, but we still stand Pluto in this household. Okay. So we used add to add Pluto because, Pluto, we still stand. We have dot size. So let's do system.out.println. And we'll do planets.size. Okay. Now let's check system.out.println. And let's see. Planets.contains. And what's a planet that we didn't include? Uranus. I was really okay. So there we go. Perfect. All right. You should be able to hear me now. And essentially, we're just testing out some of the methods. Let's see. Nope. I don't know why my mic keeps going out, but it is what it is. Let's just delete that. Add this. Add one more. Perfect. All right. And we can actually sort them. So we'll do one more. Okay. And, ooh, that's not good. Let's see. Oh, actually, that's the wrong one. Let's do collections.sort. Do planets. Okay. And let's see if this will actually run. Java void type not allowed here. I guess we'll just leave this out, maybe? I don't know. Yeah, I didn't like that for some reason. Let's see. All right, let's try running it now. Okay. So we have 5, because we do have 5 pieces. We have false, because Uranus isn't there. We have the index of Mars, which is 3. And the collections.sort planets did not sort. That's weird. Okay. So we've gone on ahead and added this. Let's try it. Let's go on ahead and copy this. And V. And let's just do planets.to array. And let's run it. Ooh. Oh, well, I'm not running it correctly, so that makes sense. Right, and that's because in Java we need to know the size of an array when we create it. So let's just copy this. Actually, no. I don't want anyone to get into the habit of copying code because while it can be useful, it's much better at this stage to just type it out yourself. So string, and it does help reinforce syntax. So planets array equals new string. And those are brackets. Planets dot size. Okay. And planets dot to array, and they will be stored in planets array. And let's go ahead and do system.out.println. Do planets array, and let's run it. Okay. peculiar. If anyone can figure that out in chat, that's your homework. All right. So the number of entries in an array list may not be modified. Technically true. Okay. Create an array list called car stars containing A, B, and C. Array list. Okay, here you have the proper syntax to start off. Hang on. I would honestly almost want to use, you can technically use D, because remember, characters are single letters where strings are potentially more. Here, technically this right here works. And with the double quote, you avoid falling into this pitfall right here where you have strings, but then you have single quotes. So I don't know if you can actually declare an array list with a primitive. That might not be allowed. So I want to say D here. But if you have a better answer, let me know in the comments below. All right, let's go ahead and move on into the arrays. All right, so we learned about arrays in Java in a previous lesson, so let's compare them to the array list. Array lists are generally easier to use than Java's array. Let's see why. Why does Java have both arrays and array list? It's historical. Java is a C-style language, and arrays are the most basic data structure in C. Using an array over an array list may be preferred in some circumstances, primarily for performance reasons. Array operations are generally faster than array list operations. Also note that arrays are fixed sized. You can't expand or contract an array after it's created, so you must know exactly how many elements it'll need to hold to create it. This fact is reason enough to use array list in most scenarios. To illustrate array usage, here's a version of the gradebook program using arrays instead of array list, and we have this in our exercises. Let's see. Okay, so fairly simple code, imported scanner. We have a max student amount of 30. We have our string array of students, our double of grades, and both of these are accounting the size of max students 30 for the array. And scanner input, we're declaring our scanner. We're doing string new student, and int number of students equals 0. Okay. Thank you for the bots that popped in. Always nice to meet a fan. So system.out.println, we start with number of students, which is 0. We ask them to enter the students. While add a new student, if the new student is not blank, we're actually going to do students, which is our array, num students, which is the number of students, and that will be equal to the new student. So we're adding new students to our num students array. Then we're adding 1 to it, as long as it isn't blank. So this will continue to loop and add new students. Then to get the grades, we have a for loop. What we've already done, we do system.out.println grade for student, input the grade, and add it at the same index as that it's added. Okay. Then we'll print out the class roster, print out the grade, and do an average sum, same as we did previously. So we've decided up front how large our arrays, students, and grades are going to be. So this program sets an arbitrary maximum number of students, likely larger than any user will enter. So it may seem obvious, but array has no equivalent add method. The only way to access or alter an element is an array is with bracket notation using an explicit index. So the gradebook defines counter variable num students. When the first student is entered by the user, the value is stored in new student. If the value is not empty string, then the item in students at 0 position, the initial value of num students is assigned to the new student value. The next time the do while executes, the value of students at position will be assigned to 1, and so on, because we will always access and assign array elements using explicit index. Our code can seem littered with array counter variables, like our friends I and j, and is more difficult to read, not to mention more error prone. Okay. Like array list, however, we can loop through an array using for each loop as long as we don't need to use the index. So if we only wanted to print each student's name and not their grade at the end of the program, we could do. Okay. So let's actually do some of this. Let's go with system.out.println, and here we're going to do students. Okay. Now let's try running it. Oh, wrong one. Here we're going to run Jussie. Got a 12. Okay. Huh. So students, which is our string array, num students, which is our number. Maybe. Let's try it. Okay. Okay. So I would love to be able to print out this students array by itself. But it looks like essentially here what it's doing is it's taking whatever is put in and it's adding it, that piece of information, into the students array, which is then equal to new student. Yeah, so it's just dropping it in the array of num students. Okay, so it's just adding it. That is weird. But yeah, I mean, it's nothing groundbreaking. So array sizes and element values cannot be changed once defined. True. Given the array below, which of the following is a valid action? Int random numbers equals new int 5. Random numbers dot add 3. This would not be. This would not be. This would technically not be. D. Why? Remember, with arrays, we don't have dot add options. So these two are automatically out. This is a string, not an int, so it would be rejected. So D is the only viable left candidate. All right, and hash maps. Now, hash maps are extremely powerful, but they can get a little convoluted. So for now, we're just going to walk along them and just, kind of read through them together. So I've pulled up the hash map gradebook in my book. So Java also provides us a structure to use as a key value pair. Java calls these objects hash maps or maps more generally, and they're provided by the hash map class. Consider the gradebook example. We can improve our program using a map. We'll store the students' grades along with their names in the same data structure. The names will be the keys and the grades will be the values. As with other collection structures, in Java, we must specify the types of objects we'll be storing when we declare the variable or parameter to be a map. This means specifying both key and value data types, which we are allowed to be different for a given map. So here we have a hash map, string and double. String will be the name, double will be the grade. Students is equal to a new hash map. So, as with other collection structures in Java, we must specify the types of objects we'll be storing when we declare a variable or a parameter to be a map. This means specifying both key and value data types. Yeah, we already went through that, my bad. So simple enough, string new student to store whatever we type in. Then we enter our student name. So if the student name is not blank, it will print out grade, and then it will request the new grade. And then it will do using the dot put. And let's see if it actually explains the dot put. So here we have hash map on line 11, which is right here. Hash map string, which is the name, double, which is the student. Let's see. Like the array list, when we call the hash map constructor on the right side, we don't need to specify the type. We can add a new item with the dot put method, specifying both the key and value pair. So dot put just adds whatever you just put in to the actual hash map using the new student, which was declared right here, and then new grade, which is determined right here. And while we don't do so in this example, we can access hash map element using the get method. If we had a key value pair of Jesse 4.0 in the student map, we could access the grade with double Jesse grade students.get Jesse. Actually try that. Let's see. System.out.println. Here we're going to do. Ooh, I keep doing that for some reason. Double Sam grade equals actually let's do double Sam grade equals student dot get Sam. Okay, and let's try running this and see what happens with our modifications. Stop running it, start running it, and yeah, that might help. Okay, and let's go ahead and run it. So let's do Sam, who got a. Am I running the right one? No, I'm not. I'm running the array. So I actually have to come up here, click play, and run. Okay. So Sam got a 100. Joe got a 75. And Antonio got a 60. Okay. So Joe 75, Antonio 60, Sam 100, and here we have Sam's grade 100. So the dot get method does work, as we've seen. Let's continue. So variables can be accessed using elements. Looping through a map is slightly more complex than it is for ordered lists. We'll look at the for each loop in this example, which is right here. For map.entry string double student, students.entry set, system.out.println student.get key, which is the, remember, key is the name plus student get value, which is the grade, and then the sum just adds up all of the values or the grades of our student hash map. So let's see, the iterator variable student is the type map.entry string double. The class map entry is specifically constructed to be used in this fashion to represent key value pairs within hash map. Each map.entry object has a get key method and a get value method, which represents the key and the value of the map items. If you only need to access the key of each item, you can choose a simpler loop. So for string, student in students.keyset, system.out.println students. And if you need the values, double grade students.values, system.out grade. Okay. Here we have some cool hash map methods for array list. well, let's collect some hash map methods the same way we have for array list. As we said for about array list, it's not a comprehensive list, just a few samples. We can check the documentation on hash maps or array list. For now, let's just do this part right here, which is, and we should be able to do this over here. Okay, so let's go ahead and declare our hash map. Man, no, I'm supposed to be this teacher here, but I don't know why. As soon as I said hash map, I had a horrible craving for hash browns. String integer, let's do moons is equal to new hash map. Okay, so now we have our hash map. Let's go on ahead and do moons dot put. We're going to say that Mercury, which is our key, has 0. Moons dot put Earth has 1. And you'll see that it's continuously erroring me out until I include both the string and the integer values. Let's see. Oh, Pluto has 5 because we love Pluto in this household, as we've already discussed, but we'll leave that later. So let's do Mars. Yeah. Moons dot put, and we'll do Mars has, how many moons does Mars have? 2. Okay, so simple enough. We do have some syntax here that we can try out. So let's do system.out.println. And let's actually, because we're going to be using this little piece a lot, let's just copy that. And we're going to do size of the hash map plus, and we're going to do moons.size. So system.out.println keyset, which is moons.keyset. Moons.keyset will actually only return the keys, which is going to be Mercury, Earth, and Mars. So let's see. Related planets are. Okay. Yep, too far. Okay. Let's do the values. Related moon counts are, and we'll do plus moons dot values. Okay. Now put, that means that we get to add a new one. So we're going to do to go ahead and put, let's move put up to the top. I actually don't need this for now. And we'll do moons dot put. We're going to add our boy Pluto back in because, you know, we stand Pluto in this household, as we've already discussed numerous times. And contains key is fairly simple, contains value. Let's see. System.out.println. Here we'll just do is Earth on the, no, not Earth. Let's do, oh yeah, is Earth on the list? Plus, and we're going to do, so this is a Boolean value, so it'll return true or false. So here we're going to do moons dot contains key, and we're going to do Earth. And we'll do one more. Let's see. Is there a planet on the list with 9999999 moons? And this is another Boolean, so we'll do moons dot contains value, and that's, I sometimes hate my own. Let's see, copy, because I'm not going to count out how many 9s were in there. And let's go ahead and run this. Let's see what happens. So we have the size of the hash map, which is 4. So Mercury, Earth, and Mars, which makes sense. We have 4 altogether. Related planets are Earth, Mars, Mercury, Pluto, and it did arrange them in alphabetical order. Related moon counts are, and we have 1, 2, 0, 5, which are not rearranged. Is Earth on the planet list, which is true. And is there a planet on the list with 99999 moons, which is false. So here's our reference. Given our hash map, moons, Mercury 0, Mercury blah, blah, blah. What is the method to return their key names? This would be moon. Well, we actually have it here. Moons.keyset returns their key names. Given our hash map, what will moons.getMars return? Did we have a get method up here? I don't think we did. Oh, that's why we can always check the documentations. Let's check it out right quick. Command F, GET. Okay. Get object key returns the value to which the specified key is mapped. Okay. So moons.getMars, according to this, it will return the value. So that should, according to this documentation, return 2. And since I think it is a double, no, it's an integer, so it should just return a 2. Okay, so with that being said, we are done. We are down to the exercises, and I'm actually going to let you guys take a shot at this before we review this as a class. I want you all to get some practice with this. I want to make sure that you all understand exactly what you're doing with these collections, because this is something that I see daily in my job as a developer. This is something that you will see a lot in all of your projects. Data structures are a big deal, so I want you to really dig into this exercise. Get as deep as you can with it. If you have any questions, drop something in the chat, Slack me directly, or reach out to me. I'm more than happy to help. As always, it's been Isaac. Thank you very much for hanging out with me and listening to me discuss all of this. I appreciate it. Have a great evening. Stay safe.